Hello everybody, today we're going to be doing 8.4 briefly. I'm going to talk briefly about what we call a vector. What's a vector? A vector is an object that has both a length and a direction. So the way you can see it, you started at one point, let's just say A, and it's going in this direction, and towards point B, you create an arrow here. This one here is vector AB, and it's written like this, vector AB. Okay, so we write vector AB to represent the vector. You started from A, you end up at B. Okay? A vector can be represented by an arrow that has a fixed length. This one has a fixed length, 10, 15, whatever it is. Okay? And what about CD? CD could be represented by what? You're starting with C, and here's D. You have an arrow towards what? D. And this is vector CD. Now, sometimes a vector can be represented by a single letter. A lot of times in the book it's in boldface, bold. So sometimes you write it vector U, for instance. So we have going from here to here. Let's just say if this is A, this is B, and this is vector U. You can call it vector AB or you can call it U. Okay, and the way we write it is U with an arrow on top of it, but in the book, the way they have it, it's in bold. So it's, you know, boldface type, and that's what you see it in the book. Whenever you see boldface type, you know that they're talking about the vector. But the way we write it by hand is the letter on top of it is the arrow, and that represents a vector. Okay? All right, so that's just what you have here. So let's go ahead and draw a vector that represents the movement from the point P, which make it -2, 4, okay, or -2, 1, let's make it, to the point Q, um, 4, 3. So let's do this. So -2, 1, x is -2, and y is 1. This is your P right here. And Q is 4, 3, so here's 4, and here's 3. 4, 3 is right here. Here is the vector PQ. So you draw an arrow from the point P, from the first point P to the second point Q, and we construct the vector PQ. This is vector PQ. All right? Okay, now you might want to draw a vector V. Draw a vector V that travels from the origin to the point 3, 5. So we can do this. So 3, 5, here's the point 3, 5. So this is 3, 5. And here's is going from the origin, here's the origin to the point 3, 5. So you draw the arrow from the origin to the point 3, 5, and this is your vector V. So this is your vector V. Okay? Right? So I want to briefly talking about adding vectors. You can see it geometrically. So let's go ahead and do this. Now to add vectors geometrically, okay, you want to draw a vector, let's just say starting, so let's just say you want to draw, here is U and here's V. So this is vector U and this is vector V. It's starting at the end of vector U. Okay, so how do you find the sum vector U plus V? Okay, so that's what we're going to be doing. So if this is U, this is V, this would be U plus V. All right. Now, I started with this to see the sum of two vectors, but they don't have to. One doesn't have to start with the end of the previous vector. For instance, here vector V, it started where? The end of vector U. Usually you don't have that. So let me show you. Suppose it was slightly different than this. Suppose you have U like this and V like this. How would you add them? Well, to add them, what do you have to do? You have to draw vector V starting at the end of U. So this is what you would do. So this is vector V, vector U. This is V. You will go in the same parallel with the same length. So this is going 1 here. It's parallel to vector V and it has the same length. So when you can, that's what you have to do in order to add the vector U and V. At least geometrically, this is what you have to do. So you draw vector V starting from the end of vector U. Okay? Same direction, same length. And then you find U plus V. Okay? Normally, it's not usually given to you like this. More normally, the vectors are not, one vector does not start at the end of the other vector. But this is what you have to do. But you have to make sure it would have to be going in the same direction, same length. You cannot make it larger, longer, and so on. Okay? All right, so this is drawing vector u plus v. So let's see. Okay, so given the following vector, so suppose this is vector u, okay? I want you to go ahead and draw negative u. How would we graph it? Negative u. Negative u will have the exact same length, but point in opposite direction. So negative u would be, same length, but in opposite direction. Okay? So it will have, let me write it down so I don't forget, will have the same length, but point in the opposite direction. Okay? So if this is u, let me make it shorter. Let's just say, call it something else. This is v. How would you draw minus v? This is minus v. Okay? Exact same length, but in opposite direction. All right? Now, how do we draw 2u or 2v? Let me make it the same as that. So this is v. 2 times v is double the length 2. So 1. Three v would be 3 times the length, but it will go in the same direction, okay? But it will be 2 times as long as v. Okay? All right. So this is a quick, we're going over this briefly, this section, and I wanted to introduce this. I'm gonna go ahead and do another problems from here, slightly different than the ones that we've that's gonna be in the textbook. I'm not gonna go into details with vector. I just wanted to go over this relatively briefly. I wanted to go over now the direction. As you know, this is will be north, and this is south, this is east, and here's west, and this direction would be northeast, and here would be northwest. This would have 45-degree angle, and here would be southeast, and here would be southwest. Just wanted to go over that with you in another video. I want to go over a bearing problem. I'll show it to you. I'll share it with you at another time. Okay, so I'm gonna stop here for now from 8.4. Okay, so we're gonna start with 8.6, and that is parametric equation. What is a parametric equations? A system of parametric equations is a pair of functions xt and yt in which x and y coordinates are the output represented in terms of a third input parameter t. Excuse me. So a system of parametric equation is a pair of function xt and yt. So we have x and y are represented in terms of a third input parameter t. So t would be the parameter, okay? For instance, let me give you an example. You have xt is 3t plus 2, and yt would be 2t plus 3. So x and y are functions, are the output, right? And represented in terms of a third input parameter t. So t is what we call the parameter. All right? These what we call our parametric equations. Our parametric equations. Okay? Okay, so these are what we call a parametric equation. This is just an example. In general, x is a function of t, x is equal ft, and y is a function of t. These are your parametric equations. Now, each value of t is a parameter, and each value of t determines a point x, y, which we can plot in a coordinate plane. Okay? So as t varies, as t changes, the point xy also varies and traces out a curve called what we call a parametric curve. Okay? So each value of t determines a point xy, which we can plot in the plane, in the coordinate plane. So let's go ahead and do that, okay? Let's have an example. Let's actually have this example here. xt equals 3t plus 2, all right? And let's go ahead and sketch the graph. Of xt equals 3t plus 2 and yt equal to t plus 3. So this is what we're going to be doing here. So you have t here. For ht, we have different value of x and y. Let's do this. Well, for t is equal to 0, what do you have? All right. So we have x0 is what? So we plug in x here to get to get the value of x. In 0 for t to get the value of x. So that's 3 times 0 plus 2. 3 times 0 is 0 plus 2, which is simply 2. So when t is 0, x is 2. Okay? When, but what is y? We plug in 0 in y, t. We replace t with 0, and we get 2 times 0 plus 3. 2 times 0, 0, 0 plus 3 is simply 3. So when t is equal to 0, x is equal to 2, and y equal to 3. So the point on the graph would be 2, 3. Okay? Now let's select other values of t. So let's go ahead and select, let's just say 1. When t is 1, what do you have? x1 would be, plug in instead of t1. So x1 would be 3 times 1 plus 2. That's 3 plus 2, which is 5. When t is 1, x is 5. You do the same thing to find y. You plug in, you replace t with 1. So what is that? y1 would be 2 times 1 plus 3, which is also 5. 2 plus 3 is 5. So the point is 5, 5. So when t is 1, the point on the graph would be 5, 5. So let's select other points on the graph. When t is 2, again, we're going to be doing the same thing. We're going to replace t for both x and y with 2. So we get x2 would be 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8, right? And let's do y2. So 2 times 2 plus 3. 2 times 2, 4. 4 plus 3 is 7. So the point on the graph would be 8, 7. Okay, let's go ahead and select other values. Okay, so let's go ahead and select, for instance, we can skip one if you like. Let's do for 4, when x is 4. When t is 4, sorry. You plug in again, instead of, replace t with 4. So x4 would be 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. y4 would be 2 times 4 plus 3. 2 times 4, 8. 8 plus 3, 11. So this is becoming large, right? Let's select a negative value. Let's go to a -2, for instance. Right? So let's also select -2. So we have x -2. What do we get here? So 3 times -2 plus 2. 3 times -2 is -6. -6 plus 2 is -4. And let's do y -2. Now we plug in, again, we replace t with -2. We get 2 times -2 plus 3. So -4 plus 3 is -1. All right. So we can go ahead and graph them now. By the way, in general, we select negative values, positive, 0, and positive values. We usually start with a -1 first. That's okay this time. We can, this is fine too. But next time we'll start with the negative values first. So let's go ahead and graph them. It's going to be a little bit tough here. It's going to be large values here, 8, 14, 11. So what we're going to do is, let's go ahead and maybe, since x is 14, so let's do this one 5, since we have large values of x and 15 here, and here we have 5, 10, -5, -10. So let's see. When t is 0, x is 2, y is 3. So a point on the graph would be 2, 3. Right? And here a point on the graph would be 5, 5. 2, 3. Where's 2, 3? So here's 2, here's 3. Right? That's point on the graph, 2, 3. Okay? And let's select the other point, 5, 5. So 5, 5. When t is 1, you have 5, 5. That's a point on the graph. And here you have 8, 7. 8, 7, so 6, 7, 8, 8 right here. So roughly you're going to approximate that's a point on the graph. 8, 7. Okay? Then you have 14, 11. 14 is here. 11 is just here's 14, 11. Then we went to the negative. That should have been first in here. Next time we'll do this first. -4, -1. So here's -4. And here's -1. And then you connect the dots here. The arrow should be in that direction. You start with the -1s first. -1 give me -4, -1, right? When t is 0, you have 2, 3. That's next. You have 5, 5, 8, 7, 14, 11, and so on. So this is a graph of. We sketched the graph of the parametric equation here in our example. Okay? So here we have this is the way you graph. You sketch the graph of the parametric equations. All right, so let's go ahead and have another example. All right, so let's go ahead and have another example. Sketch a graph of xt equal to t squared plus 1 and yt equal to 2. You know what, let me have a slightly different problem here. T squared minus 3 and yt is equal t plus 2. Okay, so let's go ahead and begin with negative numbers. So we're going to begin by creating a table of values, right? So we have, let's go ahead and do this. T, and here's x and y. So let's go ahead and select values. For instance, t, we can start with -3. How about -3 to 3? We can do that. negative 3. When t is negative 3, what is x? So x negative 3, you plug in here, negative 3 squared minus 9. So negative 3 squared is 9 minus 9, which is 0. Oh, I'm sorry, I wrote down the wrong. Sorry about that. Negative 3 squared minus 3. So negative 3 squared is 9 minus 3. So no, yeah. So that would give me what? Sorry about that. Negative 3 squared is 9 minus 3, which is what? 6. When t is negative 3, x is 6. Okay. Now we go ahead and find y. Y negative 3. You plug in instead of t negative 3 plus 2, which is what? Negative 1. So the point on the graph would be 6, negative 1. Now let's go ahead and select negative 2. So what does that give us? Do the same thing. X negative 2. Plug in instead of t negative 2 squared. Negative 2 squared minus 3. That's 4 minus 3, which is 1. Then you have y negative 2. Negative 2 plus 2 is simply 0. So 1, 0 is a point on the graph. Okay, let's select negative 1. By the way, you can do this. You can select them. There are times when you want to skip one. So you could have done negative 3, negative 1 if you wanted to. That's fine too. So let's go ahead, select, find the values of x and y when t is negative 1. So x is negative 1 is negative 1 squared minus 3. So that's negative 1 squared. That's 1 minus 3, which is 2. Y negative 1. When t is negative 1, y would be negative 1 plus 2, which is 1. Okay, let's select 0. Are you guys okay with 0? If we do it directly, 0 squared is 0. 0 minus 3 is negative 3. And that will be x. For y, when t is 0, 0 plus 2 is simply 2. Okay? Let's select another point, 1. X is 1. What is this? That's 1 squared minus 3, which is what? 1 minus 3, that's negative 2. What is y1? Y1 would be 1 plus 2, which is 3. So you have negative 2, 3. Okay, we select t equal 2. Okay, plug in for t2. So now x2 is what? X2 is, so remember x is t squared minus 3. So 2 squared minus 3, that's 4 minus 3, which is 1. Okay? Now let's do y2. y2 is 2 plus 2. Remember, yt is t plus 2, right? So I replace t with 2. So 2 plus 2 is what? 4. So when t is 2, y is 4. I think that's enough, but I told you let's go from negative 3 to 3, so let's do this. When t is 3, what do you have? You get, let me go ahead and write it down here so you can see it with the equation. So x3 would be what? 3 squared minus 3, that's 9 minus 3, which is 6. Same as that. Anyway, we have symmetry about the y-axis, right? And y3 is what you replace t with 3 plus 2 is 5. So 6, 5. So we're going to now go ahead and graph it. Okay, so let's go ahead and graph this. Let's see. So let's take a look. The smallest x value is -2, so we don't have to go by far here. So you have -2 here. And the largest x value is 6. Y, so you have -1, it's an increase by 1, isn't it? You have -1, 0, 1, 2, if you want to do this one, you can do that as well. So let's go ahead and plot the points. You have 6, -1, so you're plotting x, y, remember? 6, -1. When x is 6, y is -1. Here you have it. When x1, 1, 0. So you have 1, 0, that's right here. That's your x-intercept right there. Then you have 2, 1. Okay. X is 2. I'm just noticed that there's a mistake here for y, for x, when t is -1. -1 square is 1, 1 minus 3 is -2. Oh, you see it? Sorry about that. 1 minus 3, when t is -1, here I plugged it in. X -1, -1 square minus 3, so that's 1 minus 3, that's -2. I accidentally wrote 2 here. Sorry about that, I'm having a little pain here. Let me see if y is correct. -1 plus 2 is 1, that's correct. So okay, so let's do this. This is better. When x is -1, y is 1. So x is -2, y is 1. -2, y is 1. So that's why you have to be careful. I keep looking at the recording if you can view it, and I accidentally wrote 2 when the answer is -2 also. I'm having a slight pain in here in my hand, so sorry about that. Make sure you have you go over them, make sure you get the right answers, okay? So when x is -1, y, you have the point -2, 1. Here's -3, 2, -3. I said the smallest value is -2. No, it's -3. So x is -3, y is 2. So there you have it. Okay. Now x is -2, y is 3. X is -2, y is 3. There it is. And you have x1, y is 4. x1, y is 4. You can tell it's a parabola, right? Open to the right, maybe. You see it? And then you have 6, 5. So x is 6. X is 6. And you have y is 5. And yeah, that's a parabola that to the right. So we started with this t equal -3. Okay, we're starting from here, right? So the arrow is going this way, and then this way. Okay, this way. Okay, t -3 all the way to t equals 3. Okay. So again, each value of t determines the point x and y. When t is -3, the point xy is 6, -1, and so on. So each value of t determines a point x and y, which we can plot in the coordinate plane, just like we did in this example and in the previous example. Okay, everybody, so I found a problem from the book that I like, that's number 3. They're asking us to match it to a graph. We can do that a little bit later on, but first I really would like us to actually graph it ourselves. So as you can see, you have parametric equations, t equal 4 sine t, yt is equal to cosine t. So let's go ahead and graph this. So select different values of t. Now the t that we have to choose, now we have a sine, cosine, so you want to probably use radiant, right? Like 0, pi, 3 pi over 2, different values. I would recommend to select the 0 pi over 2, a pi, 3 pi over 2. So let's do this. 0, and then pi over 2, pi, 3 pi over 2, and 2 pi. You probably don't need this. You'll see what I mean in a second. Now when t is 0, what do you have? If you plug in here sine 0, so let's do this. x0 would be what? 4 times sine 0. What is sine 0? Sine 0 is 0, so that's equal to 0. Now y, plug in 0 for t and y, and that will give us 2 cosine 0. What's cosine 0? Cosine 0 is 1, so that's 2 times 1, that's 2. There you have it, 0, 2. That's 1 point on the graph. Now let's go ahead and select pi over 2. So again, plug it in x and y. So x pi over 2 will give us 4 sine pi over 2. Now if you recall, sine pi over 2 is 1, right? So you have 4 times 1. That's simply 4. If you want to remember this, remember the points here. This is 1, 0. This is 0, 1. This is -1, 0. This is 0, -1. The second one is a sine. The first one is a cosine, right? So sine pi over 2 is 1. 4 times 1 is 4. Now y pi over 2 is what? Y pi over 2 is 2 times cosine pi over 2. You know cosine pi over 2 is 0. So 2 times 0 is 0. Cosine pi over 2 is 0. So 4, 0. Now sine pi. Sine pi is what? Is 0. Remember, the sine is 0 for 0 pi to pi. All right, so sine pi is 0. 0 times 4 is 0. Okay, now let's go ahead, plug in pi in y. So y pi gives me what? 2 2 cosine pi. Remember, cosine pi is -1, as you can see it here. 2 times -1 is -2. Okay, 3 pi over 2. Now again, plug in 3 pi over 2. So what do we get? X 3 pi over 2 is 4 times sine 3 pi over 2. This is 3 pi over 2. This cosine sine, that's 4 times -1. That's -4. Okay, so when t is 3 pi over 2, x is -4. Now, if we plug in 3 pi over 2 in y, you know cosine 3 pi over 2 is 0. Remember, the cosine for pi, 3 pi over 2, 5 pi over 2, 7 pi over 2 is always 0. So this is 0. I don't think you need this because this is going to come back to this. You probably figure out the graph once you plot them. But when you have sine 2 pi, remember sine 2 pi is 0. 0 times 4 is 0. What is y 2 pi? Let's see, y 2 pi is 2 cosine 2 pi. 2 pi is simply 0, so 2 times 1, that's simply 2. So we went back to here. Let's go ahead and graph this. I don't know if you can recognize it just by looking from here, but if you want to graph it, we can do this. So x is going from -4 to 4. And y going from -2 to 2. So you have, oh, this is larger. To make it look more even. So you have -4. So you have what? 0, 2 here. I forgot to plot them. 0, 2, 4, 0, 0, -2, -4, 0, and we're back here. So 0, 2, so we're starting with this. We went back. Isn't that an ellipse? Right? That's an ellipse, isn't it? So if you go to the book, they're asking you to match each set of equations with one of the graph. So number 3, that would match with graph E. Okay, graph E. So that's an ellipse centered at the origin. Okay.